Thank you, DJ Ting Song, for the wonderful opening performance. And now, welcome on stage DJ Ting Song to explain about his performance.
Thank you, everybody. I'm gonna run to the stage and yeah, all the music and the image you just saw, actually they're from AI algorithm. They're not made by human beings. They're made by AIs. I want to use this scene to inspire all the hackers for participating in ETHVIETNAM that we could actually use some new technology to make something new to the world. And I used butterflies and I translated some Vietnamese traditional culture metaphors from Vietnamese language to English. And meanwhile, I translated several Chinese traditional poems to generate all the visuals you have saw just now. Meanwhile, I could see two virtual human beings standing on the stage just now, and they too are called Mina. Mina is from Vietnam. Yeah, Mina is a girl. Yeah, and the name is by me. So Mina gonna sing a song for all the hackers tomorrow. And tomorrow, if you're one of the hackers, you will see how Mina is singing a song with an AI song. Meanwhile, you get your pull-ups NFT tomorrow after seeing the video. And I wanna use the whole show to express my idea on talking about cutting-edge technology and traditional culture. That we, Asia, have very splendid traditional culture, and for all the young talents today showing up in this room, you may be hackers and you may be other kinds of builders for Ether technology. Why not we choose some new way to express our cultural identity? And that's all I want to share with you. Come on. Thank you.
Thank you so much, DJ Ting Song, for the wonderful performance. And welcome all of you to ETHVIETNAM 2022. Dear our beloved guests, it is our honor to have you here today to join with us on this distinguished event. As you know, the blockchain Billathon is a valuable tool to engage with and solve the world problem. Being aware of this, we took the chance to bring you a kind of event in which we will build, learn, and share together. First of all, welcome on stage Ms. Queen Zhang, founder of ETHVIETNAM 2022.
Hello guys, and welcome to the hackathon of ETHVIETNAM. Thank you for joining us today. So first of all, this is the first time that we do the hackathon during ETHVIETNAM. So I know that we have about 200 people registered for the hackathon, and also a lot of teams also submit online, and right now also do the hackathon virtual at the same time. And today we have about 27 teams to join in person. And up to now we also have 40 projects submitted, but we have more time for many other activities, allowing for the useful insights, integration with an existing open source wallet or platform using block pool data, liquidity analysis, integration with existing Oracle system, liquidity routing for best execution. We also have all the mentors and the judges for each team here to support all of you guys if you want to join any bounty reward, and you can directly to talk to them. For block pool, we also have the prize pool here, as you can see. First 5K, second 3,500, and the third one 1,500. And next, score bounty reward. So you see that ETHVIETNAM, for this time we focus on the layer 2 content, right? So that's why we have many layer 2 teams here to support the local community, and SCORE is one of our sponsors for that. So we will set up 3 awards from score like gold, silver, and bronze. Can I have? Yeah. And then any creative application, open source, dev tooling, developer, and researcher education onboarding projects, Ethereum research improvement. And please note that, after all of these like bounty, also score also like willing to help you, to mentor you, to develop your ideas even after ETHVIETNAM. If they see that like you guys have the good idea and the good project, and they have the good team can support and mentoring even like for months after that, if they see that it's really worth it. And for radio, we also have the first prize 3K, second 2K, and the third 1,000. And view in-app and in-game NFT application using radio scalability solution. And this is DoraHacks bounty. We also have 5,000 bounties from DoraHacks. Like view ERC 4337, use zero knowledge proof, cross layer 2 data, efficient ZK EVM, and local Vietnamese Ethereum developer community. Next is the bounty for beatdown. We have 5K. So actually, I see that in this room also like many familiar faces like who had joined our Soju house in Hoi An. So ETHVIETNAM had like do the Soju house, the hacker house together with like beatdown for the last 8 days in Hoi An. And I see that many of you also are super happy with the Soju house. And many the hackers also like bring the idea to join ETHVIETNAM bounty for this. And for beatdown, we also have 5K bounty. And this is all the explore, like you can try with the ideas like ideation, gamification, moderated environment, membership NFT expand, proposal stage gate and support, incentives, vote rates, committees, polling, secret ballots. Wow, so many bounty. Even that I read like it's super long, so I like trying to keep like track moving forward faster. And next we have the token launch bounty, and here are the the bounty tasks here, and this is the reward from token launch. We have 3 ranks of price: 2,500, 1,500, and the third one is 1,000. And as for on, we also have the bounty details here, up to 2,000 USDC. Hyperlane, we also have all the bounties details here. 2K for the best use of Hyperlane interchange API, 1K best use of Hyperlane DeFi related, 1K best use of Hyperlane NFT related, and 1K best use of Hyperlane infrastructure. And last but not least, we have Game 7. So for Game 7, they also like join the bounty reward like very for us and focus on the Game 5 part, and have like 2 bounty, the Game 7 bounty 1 and bounty 2. So this is the ideas that you guys can see. Okay, so that's all the information about the bounty. And if you guys want to read and to do like focus on each bounty, please also connect directly to the mentor, the judges to support you. And also, we will have many workshops after this. Each team, each mentor, each sponsor will join. And this is like all the sponsor for ETHVIETNAM for now. So in order to help you in terms of logistic thing, right now we also have the Wi-Fi. We also have the communication channel on the Discord channel. So please go to ETHVIETNAM channel and go there, and we have the different group. You can ask any general question in the question and answer, or if you have any question to each bounty reward, please go there and ask, and we also have like sponsor and mentor go there and support you guys. Okay? And what's next? How many time that you got? Since like we started like 1 month already online, and also now like many team also join in person for now, and we trying to expand the submission until 9 a.m. tomorrow morning. And then after that, we will have the judge to score of your project. We estimate like about like 2 to 3 hours in the morning. And after that, we choose like ETHVIETNAM, bounty, teams, winner, and also like bounty reward from each sponsor. And after that, we choose the best 10 team. And also like we bring the best 5 team to join the demo pitch day on the afternoon of 26th. Okay, so let's start the hackathon and hope you guys enjoy it. Thank you so much.
Thank you, Miss Quinn, for the wonderful speech. And now, please give it up for our mentors, Just Bounty. Let's give them a warm welcome. Thank all of you for being here today to share with us your valuable experience. We really appreciate your time on this event and hope we could have a great moment together. First of all, I would like to introduce to you our first topic, which is how to build using 1-inch limit order protocol. Please give a warm welcome for Mr. Nikita Kolos, backend engineer lead of 1-inch.
Hi everyone, my name is Nick. Nice to meet everyone of the specific structure. After that, this user needs to share this limit order through our API. Basically, it just needs to share the structure, the conditions of this order to everyone. And next, you just need to wait until it will be executed, until somebody will be okay to execute this order. So another party who actually executes the order is market taker. It's basically someone who wants to earn on this trade, who is okay to trade with these conditions. The best example, it will be actually if, let's imagine that there is exchange rate, for example, like right now for one Ethereum, it's like 1,200 DAI. Let's imagine someone wants to trade one Ethereum for 1,010 DAI. If it's okay for you, you can arbitrage this case. It's okay for you to execute this order. So basically, you can earn some fees on executing these orders. And that's what market takers do. They basically arbitrage the market and just get the profit into their own wallets. So basically, what market taker needs to do, basically, you just need to search for basically suitable okay limit orders via 1-inch API or using P2P, for example, communication. After that, we need to fill limit order using a smart contract. And actually, you just need to also have some assets to fill this limit order. Basically, if you need to fill limit order with DAI, you need to have some DAI on your wallet and have approval for that. But basically, the whole communication between market maker and market taker. So the overall scheme is kind of like this. So firstly, we need to sign and send an order to the API, to the storage. The market taker needs somehow to search for this specific order. After that, we just need to execute this limit order, and market maker will get funds from market taker via smart contract. The main idea here is that we execute all limit orders on the smart contract, and there is a guarantee that specific constraints, specific things for this order will be executed. There is a guarantee for that, for these conditions. So let's talk a bit about limit order structure and how it looks like. Basically, there are multiple ways how you can use limit order. There are 2 options. The first, easy one, is using API on JavaScript. If you just need to create or fill limit orders, for that case, you just can use the JavaScript utils library. It's open. It's actually available on 1-inch documentation site. I will show the links a bit later. That's the first option. The second option is you can actually adjust limit orders to build something more on it. For example, we can build marketplace of NFT based on limit orders, as an example. Basically, limit orders allows you to trade any asset, not only ERC20 asset, but actually any asset, even NFT asset or any asset that can have some specific interface implemented. So I just want to tell you more about limit order structure. It will be pretty useful for you if you want to go deep, if you want to somehow to change the structures or go to the solidity part of limit orders. Just want to say that actually it's open source, so you can take a look on it, you can fork it, or do anything with it. anything you want. Basically, I just want to pay attention to some things. The first one actually is making amount, taking amount, take your asset data, and make your asset data. These fields actually allows you to specify how you can execute, how the tokens, what is the rate of your limit order. For example, sometimes there are cases when you have linear, like you have static formula of static rate for your limit order. So that doesn't matter how much like you fill this limit order, the rate will be the same. But if you will implement functions using maker asset data and taker asset data and get making amount and get taking amount, you can actually specify the rate for each type of for each moment of filling the limit order. That basically means you can build, for example, auction, like Dutch auction, for example, on limit order, on our limit order protocol. Also want to give you to take a look about predicate, permit, and interaction fields. Basically, these three parts are pretty important. Basically, permit allows you to actually, we do support permits on most of the Ethereum ERC20 tokens. So if tokens support permits, you don't need to use gas to make approvals on the smart contract for this token. You can just sign a structure for that. It's pretty useful if you don't want to pay any gas from user side. Predicate is a pretty cool feature that allows you to specify additional conditions. We have multiple default conditions like timestamp constraints, I will talk a bit more about predicate later. And also interaction actually is like a callback. You can always use interaction to do some operations with user funds before it will be executed and transferred to the taker. So that's how actually you can fill limit order. Basically, this is the main function for order execution. You just need to call fill order function on the Solidity side. We do have a JavaScript implementation for the fill order. So basically, what do we need to fill this order? It's just actually v4 signature for type signed data, v4 signature for maker address. In some cases, it can be a wallet, or in some cases, it can be another smart contract. It depends on. It actually doesn't matter. You can execute order on any contract. But I just want to pay attention that if you use smart contract as a maker, you just need to implement the signature function to verify the signature from your side. So making and taking amount is actually the amount that you want to fill. There are multiple types of limit order. In the default one, you can fill limit order multiple times. It depends on the remaining amount of maker and taker. But basically, you can specify making or taking amount that you want to fill, and we will calculate the returns for it. And the threshold amount is actually its main return amount. Basically, it means when you use taking amount. Let's talk a bit more about predicate. It's pretty awesome feature that actually makes limit order not only a limit order, but actually more like arbitrary execution, arbitrary trading, gasless trading stuff. Because we allow you to actually build any custom predicate on our limit order. So you can, for example, make a predicate that says if the DAI price goes below than 1,000, I don't want to make a limit order for my trade of link to Ethereum. So basically, you can use any predicate that you just need to implement it on the smart contract level, and there are some default ones like for example, like pinning on the market side on the limit order. Or like timestamp below condition that allows you to actually execute trades for during the specific timestamp. So yeah, a bit more about get taker and get maker amount. Basically, there are default functions that shows how we calculate the rate of each amount, but you can actually re-implement it, and if you will re-implementing it, basically, that means that you can have your own price formula for each type moment when your limit order will be filling. And a bit more about execution of the limit order. Basically, each time we execute limit order, we use actually this code. You need to take a look on it. If you will try to use, for example, a smart contract, you need to implement a specific additional call that allows to check signature from your smart contract side. Yes, this is the case. Basically, how we validate signature on the smart contract side. This is like an example of the calling is valid signature on your side. So each time you use a smart contract, you need to implement this callback. Let's talk a bit more about interaction and the use cases for the interaction side. The best use case for interaction potentially can be a case when you need, on the default cases of limit order, when you use a limit order, you need to have a funds on the user side, not locked anywhere except limit order. Basically, each time you execute limit order, by default, you need to have user funds locked somewhere. But in our case, you don't need to do this. You can basically, for example, stake some assets on Compound or like on the Aave for the DAI, and on the moment when all the limit order will be executed, you can use interaction to actually withdraw user funds from the DAI and fill this limit order at the same moment. So basically, you can do multiple things at the same time. You can, for example, sell something for the DAI or like buy something using DAI, and also do some API like farm or staking somewhere these tokens. You can do everything like in the same moment, and for that you basically just need to implement interaction. Yes. So basically, there are two options how you can start using limit order. There is a quick start on our documentation portal. There are multiple examples how you can use it using JavaScript. It's like the first core code. And also there is open source code of all our limit order on the Solidity side with tests on the right. Basically, if you want to use limit order using smart contracts, I do recommend you to take a look on our tests and on the right link of limit order. And I also want to say that actually right now we are working on V3 version. It will be available like in the next couple of weeks, and it will allow you actually to use limit orders in even more gasless way than right now. It will be even more efficient, but currently V2 is the last production version, and I think the transition to V3 will be actually pretty painless. So thank you. If you have any questions, you can ask me. I will be here.
Thank you, Mr. Nikita, for your wonderful sharing. And now we would like to move on to our next topic, which is utilizing on-chain data for DeFi analytics. Allow me to introduce on stage Mr. Braden Abrich, founder and CTO. Welcome on stage, Mr. Braden.
Hi, good morning, everyone. My name is Braden. I'm the CTO and founder of Blockboard. It's super exciting to be here presenting a workshop. I myself am a hacker, so usually I'm on the other side of this, not up here. One fun fact is Blockboard as a company was actually born out of a hackathon. So I'm super excited to see what you all build. I think it's a really great opportunity to meet other people and build some super cool stuff. So the topic of this workshop is utilizing on-chain data for DeFi analytics. And so we can go through some of these slides here. So the first question is, what is Blockboard and what do we do? At a very high level, Blockboard is an on-chain data and analytics company. We provide on-chain events, on-chain transfers, and a lot of our specialization right now is around decentralized exchanges. And so if we look at some of the different problems that Blockboard is trying to solve, we can see the first one being data asymmetry and fragmentation. And so right now, if you look at aggregated cross-chain data, you can see different dexes like Uniswap, SushiSwap, etc. And all these different DEXs and all these different platforms are essentially competing with each other for liquidity. This is ultimately a bad user experience for people who are trying to interact with these different applications. The more sources of liquidity that are segmented, basically means that users have to pick or choose which DEX they use, or they could use an aggregator like 1inch or Matcha. And so what Blockcore does is we basically pool all this information into one source, one dashboard, and allow users to see all this data in one place without having to use several different platforms. The second problem that Blockcore is solving is around latency with data. And so as traders in the space, there's a lot of opportunity to build smart contracts to do things like arbitrage. And so with Blockcore, we offer WebSocket APIs, also RESTful APIs as well. And so you can basically get live data from all these different sources of decentralized exchanges across all the different ecosystems that we support. And this data comes in real time as well. The third problem that Blockcore is solving is unreliable data feeds. And so what this basically means is a lot of existing data providers out there are using third-party APIs. So you've probably seen data providers use things like CoinGecko or CoinMarketCap or Binance data. For Blockcore, all of our data is derived on-chain. So everything you see on the platform, everything you see on the APIs, we're deriving all that information ourselves. And we don't use any type of third-party or centralized data provider. So if we go over the solution and what essentially Blockcore is and what we've built, there's a couple different points here. So the first point is around our indexing infrastructure. And so basically at a very high level, Blockcore runs archive nodes on all the different networks that we support. And so on the right-hand side, you can see the different networks that we support. So we support Phantom, Avalanche, Arbitrum, BNB Chain, Optimism, Moonbeam, Polygon, and a few others. And we basically run nodes on all these different networks. And as events and as transactions get mined, we basically extract certain segments of events from these different networks, and we feed them straight into our APIs. So as a user, you can instantly see data across all these different networks in one place. So instead of having to query Ethereum and Phantom separately, with Blockcore, you can see everything all at the exact same time. The second point here is around multi-chain data aggregation and UI. And so as a user, if you want to see what's happening on the Ethereum network, you might have to go to one website and you can get information about events happening on Ethereum. With Blockcore, as I said earlier, everything is aggregated in one place. So with our APIs, you can actually see the price of wrapped Ethereum across all these networks instead of just seeing it on one network or the other. The third point is vertically integrated node ops. So one of the power sources of Blockcore as a company is, as I mentioned, the fact that we run our own node infrastructure. So we run archive nodes ourselves, which gives us full access to all this data in real time. And we're also able to query data going back to the Genesis block. So Uniswap in 2018, we would have data. We would have data in 2019. And so if you're a trader and you want to backtest trading strategies, you'd be able to use our APIs to basically see historic data and historic trades as well. And so if we look at some of the different things that you could do with Blockcore, build with Blockcore, you could obviously take a look at our app, which is app.blockcore.com. And this is basically our representation of what we're doing with our data. Obviously for the hackathon, you are all welcome to build any type of application that you want. But our front end might give you some ideas of some different things that you could do with the data. So we have a couple points here, obviously asset prices, swaps and transactions, liquidity pool events, token transfer data, and also real-time and historical statistics. And so on the right-hand side, you could see a sample widget on Blockcore that we built. And this is all using the APIs that we have. So you could build price charts, you could build live trade tables, you could build live liquidity pool actions. You can also show things like liquidity pools and kind of how different traders are interacting with these different on-chain assets. So what can I build with Blockcore for the hackathon? And so there's obviously tons of ideas. We've offered a couple here. So obviously around visualizations. So as you've seen on our app, you're all welcome to build your own visualization or your own application or front end with our data. You can build some tools for liquidity analysis. There's also some opportunities for building some smart contract arbitrage bots around our data as well. I know that 1inch had just gone over some of their stuff that they're doing for the hackathon. There could be some cool opportunities, obviously, to integrate some of that stuff into what Blockcore is doing with our data, to obviously make trades or build trades on top of that as well. So here's a sample API demo. So we have our API publicly available. We deployed it for this hackathon specifically. And so you can view our API at block4.readme.io. We can also provide a link for that afterwards. We have a couple really basic rate limits right now. We can obviously open these up as well if there's certain teams that need to make more requests. There's currently no API key required, so there should be no blockers to start using our API. You should just be able to go to the API site and start making requests right away. One caveat here is some of the endpoints are cached. So some of the historic endpoints themselves, we will be caching the data on them. We will outline which endpoints are cached so you as a user can get familiar with that. And then on the right-hand side, we have a very simple example of one source of data that you could use, which is basically an on-chain transfer event. And so I think most of us here are familiar with the unfortunate collapse of FTX. And during the collapse of FTX, there was a lot of interesting on-chain movements of funds moving between FTX, between Binance, between Alameda. And so with Block4, we actually analyzed on-chain transfer events as well. And so you as a hacker could actually use our on-chain transfers and start building some interesting visualizations or some interesting tables about how these different entities are sending funds across these different networks. And so on the right-hand side, we have a sample object of a transfer event. And so we have things like the time of the transfer, the block number, the token that was transferred, the receiver and the sender, the network, and then also the entity names as well. So you could see things like an FTX to a Binance or an Alameda to a Binance, and we would be able to derive all this information for you. And then, yeah, finally, we have a link to the API there as well through the QR code. We also have a booth here set up, so if anybody has questions.
Oh, in blockchain, we only believe in cryptography. In math, we believe in signature. We believe in proof. So that's very crucial. But in some of the solutions, like side chains, in that case, you have to trust entity, no offense, like BSC, like Polygon, and they are trustworthy, I mean. But couldn't we have a better way that is just like Ethereum mainnet? We have to trust the consensus itself. So that is the base differences between layer 2 and other scalability solutions. That is, the security is based on Ethereum mainnet. Let's make an example. In traditional information security, you have VPN. In some big companies, you have to connect into your VPN using your credentials and inside the LAN and to access anything. But once you penetrate it or get inside the VPN, basically you are free. Hey, it's database everywhere. You can dump them and do bad things about it. So now there's a new concept called zero trust, which is for every step you've done in the LAN of certain corporation, they have to be audited. That is, whether it's read, write, or update, they have to be audited thoroughly, and every step there must be a confirmation. So it is the same in layer 2 and blockchain and so on. Instead of trusting human, trusting some nodes, some validators, there will be some sequencers, watchers. Instead, we want to trust code, trust math, and trust proof, trust hash. So yeah, finally, we are mature enough to have something at least vulnerable layer 2, be it optimistic roll up or decay roll up. And yeah, maybe there is some, of course, a lot of you already knew the future development of Ethereum, but for some of you, there's one critical concept called abstraction in computer science, which is, yeah, credits to EMKYCCTV on Reddit. This one is pretty easy to understand. So abstraction is not something like Picasso's paintings. No, abstraction is that if we have one thing very complex, we just try to make it modularized and separate into a lot of different parts. And between those parts, they just have to follow some standardized procedure. Like in TCP/IP, we have TCP/IP 7 layers or 5 layers, right? And if you are doing applications, you don't have to know how router works. You don't have to know how BGP protocol works. All you have to know is, hey, I have a socket connection. And because all the others underlying mechanisms, they have been abstracted. And it is the same, exactly the same is happening. History is repeating again in a good way. On Ethereum, so yeah, we have data shards, we have consensus layer. By the way, this is the security part. and execution layer. And for consensus, that means in a very simplified way, that means how to produce block, how to determine the sequence of block, what kind of transaction should be included in a block, etc. And for execution, it's all about state transition. I mean, previous state, n-1 state, and a lot of transactions. They want to execute all of those transactions in a certain order, and they got transited to a next state, right? So that is execution. And execution is very, very resource intensive, and that is why Ethereum is now one of the main reasons. So yeah, please look at this. Oh, let me make it bigger. So yeah, bridges, we all know that. We all love bridges, and we all hate bridges because a lot of the, accidents. Yeah, so in alternative L1, some other main chains, or in some side chains, there's only bridges. So we have to trust on the provider of that side chain or that L1 in order to bridge your assets from Ethereum to the side chain. But bridges alone are not ideal. So yeah, let's take a look at this part, roll-ups. So to explain roll-up in a more active way, we are called scroll, right? So when you are doing a scroll, it is like bang, and you roll it up. And instead of it's so big, now it's so small. And roll up is things like that. By taking out some unnecessary parts in the transaction, and the transaction metadata can be a little bit fewer. So yeah, the data storage will be a little bit less of a problem, but it's still a problem. I won't talk about that today. It's called data blocking. But yeah, check at this and make it bigger. Proof, right? Instead of bridges only, now we have proof. So that is why I talk about information security. Talk about we have to trust math, not people. As long as we have proof, and we are fine, because now the proof can make sure trust no one from the X file. The proof can make sure that no one is, say, lying, or no one is acting mistrust. We don't have to believe on the watcher. There's no more, or at least not any more complex mechanisms for the different kind of contract implementation. So it's zero-knowledge proof only. So it is very cryptic. Even I gotta admit, I'm an applied cryptographer, but even I do not know a lot of the details and nuances in the zero-knowledge proof. So in order to make it simpler for everyone, here's the very, very easy analogy to it. Thanks to Elizabeth Sasson from Sauer, his paper is really well written. So outsourcing tax calculation. For example, now it's tax season, we all hate that. And the government is being even more lazier. They are like, hey Jerry, this is your tax data, but we are too lazy to calculate it for you because we, government, our IT is bad. And I'm like, no, so I have to calculate it myself using my computer. So can I cheat on it? Considering X is something that your government knows, that is your tax data. And X is something I know because it's my tax data. And formula f of X, thinking it's 1 plus 1, 1 times by 1, etc., math formulas, and equals to Y. Y is the result to the amount of tax that you gotta pay to your country, not your nation, not year. But can we rely on it? Of course, yes. Just like we will do wrong on our math test, we will do wrong on this too, whether we meant to do it or we are acting dishonest. So what's the result? So how do we solve it? So there's a concept called computational integrity proof. That is, we want to make sure using some, math magic. That is, we can make sure, for example, if we were to calculate 3 times by 2, we have to plus 3, that is 6, right? But if we have to count like 3 times by 7, and we have to like plus 3 for 7 times, and each step, one step, 3 plus 3, 6, 6 plus 3, and 3 plus and 9, 9 plus 3, etc., etc. So computational integrity proof is that although no one is watching over me by using some magic, cryptography magic, the receiving side can ensure that, hey, I look at your pi. Pi is generated together with this formula. By looking at your pi, I know that, hey, you've done every step correctly. By correctly, we mean that, A, the X is correct because for your government has X, right? And I have X, right? So government can use their X, which should be the same as our X, using the same f of X, the formula, and they don't have to calculate themselves. Instead, they just look at pi. You know, there's one thing called trapdoor function. That is when you, okay, let's talk about win RAR. If you have to archive something, it's slow. But if you have to decompress something, it's fast, right? So calculating this is slow, but looking at pi is right. So for government, this computational integrity proof magic can help them, like they are essentially outsourcing the computation, the hard part to us. And they have to only to make sure that the pi is correct, provided by X, and Y is correct. And that's all. So the government don't have to worry about, A, their computers are not powerful enough, and B, the proof is easy to verify, so everything is correct. And why were I having this example? Deja vu? Do you recall this one? So the point on Ethereum L1 is that Ethereum L1 is slow due to some technical debt or community debt. So we want to outsource some computation to some other entity. And that is the same situation here. The government wants to outsource their tax calculation to people, but they do, instead of trusting people because people will lie, we don't want to pay taxes, right? But so there has to be a proof, and it is exactly the same in this case. Like we want rollup to provide proof so that all the state transitions is done correctly and can be verified by everyone. By everyone, I mean everyone, just like you and you and you. We have GitHub, not we, our community has GitHub open source repos that can make you to verify the rollup proofs on chain yourself. It's pretty interesting. Yeah, so Squirrel, we call ourselves a scaling solution for Ethereum. We want to make Ethereum faster together with everyone else, every other L2 solutions. And so Squirrel is also an EVM equivalent ZK rollup. So yet another buzzword. Maybe I will not call it buzzword. Yet another hard to understand word. What is EVM equivalent? Yeah, so the point is, I was talking like this is something so easy. But in fact, the f of x, in order to like converting this calculation into something that is that can be fit into zero knowledge proof systems, it's not trivial. It is very hard. And how hard? Let me raise an example. I mean, a lot of you are Build-A-Song participants, right? It is very, very, very hard for you in order to deal with some very low-end concepts. Like we're all very familiar with high-end languages, but if you were to say write your code in assembly language, what would you be like? You'll be like, hey, my head is exploded. So it will be the same thing happening in zero knowledge proof if we were to write those things in circuit. By circuit, that means circuit. Just understand circuit this way. So in zero knowledge proof, you have something you want to prove, be it layer 2, be it transaction data, or be it text calculation. And in order, we want to transform that into something called circuit. So that people, when they are looking at proof, they can run the circuit to see it is right. So think circuit as the calculation itself. And yeah, the way languages like Circon, it is very hard to write this kind of thing because it is prone to error. And you know, people like us, we all prone to error. There's many rug pulls on Ethereum on blockchains all the time. So in software engineering, one thing you have to remember, if some languages it's very hard to make something wrong, like the memory management is bad, or the scope is bad, the scope of the variable is bad, and people will fail. And this is not ideal if we were to write those proofs ourselves as general smart contract engineer. So what to do? Yeah, also having to write a proof for every contract written, it is also annoying because it's hard. So remember abstraction? Yeah, it's abstraction again. So instead of doing anything on the upper layer, can we do anything in the bottom layer so that everything is taken care of? Like in TCP IP, we don't have to know about the BGP, the routing protocol. We only have to worry about the top layer, right? So in this case, the top layer is smart contract, and in the middle layer, maybe it's gas, so Ethereum, the client, and in the bottom, it is EVM, Ethereum virtual machine, where we execute the state transition. So instead of abstracting the topmost layer, how if we were to abstract the bottommost layer, and the hardware should be done by engineers like in Squirrel in software, or in DKC in STech, things will be solved, right? So yeah, maybe not that easy, but we have a glimpse of all. So yeah, you see. Okay, so the point is what is DKEVM? How do we make a proof? So that for gas, so Ethereum, we have some execution traces. Remember we say like 3 times by 7, we plot it by 7 times. And it is the same in gas. There is execution traces like program counter 1, 2, 3 in assembly languages. And we just grab the traces and try to convert it into the circuit input. By circuit input, I mean f of x equals to y, right? And the x is the circuit input. That is something that we want to prove. Hey, we've done the calculation, feeding input x, and output is y. And so they will be fit into different opcodes in the EVM, like the RAM circuit, event circuit, storage circuit, other circuits. The interaction here is complex, so I'll just keep it at the time. You can check our YouTube channel for more details. And after that, we just aggregate the proof into one big proof. Then it's done. So here is a brief comparison to all of the maybe not all, sorry, to some of the L2 projects, so on. You can see that the difference here is the abstraction level is different. I'm not going to attack or say anyone. If I say anything wrong, please, I don't mean to offend anyone. But the point is, if you do abstraction in different level, you got different trade-off. Like if you did a thing like Starnet did, I can assure you that the performance will be very, 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 very good. But in the same time, people have to learn how to write carol, or people have to learn how can we transpile, how can we convert our code from Solidity to carol. And that is one thing, that is another engineering thing that has to be done by the excellent people in software or in the community. So yeah, from the left to the right, that means the trade-off in the where in the left, the projects tend to be more efficient and flexible, but in the same time, they are a little bit less, a little bit less EVM equivalent. That means some opcodes may not be supported, or some behaviors might be a little bit different from Ethereum mainnet, and you have to change your code, but they are efficient, right? So from here to here, you can see that the abstraction is happening in the language level, in the compiler level, or in the assembly language level. Like in Polygon Hermes, they have assembly in between virtual machine to deal with opcode and their storage status, etc., etc. But in Squirrel and Ethereum, we try to do it the hard way. By hard way, it means that the efficiency may be not so good at the moment, but it will be so good in the future, because you can try our testnet, by the way, it is already good. So that we aim to make every developer here, that is you and you and you and you don't have to learn anything about Squirrel. You just open your hard hat, open your Foundry or even Remix ID, which we will do in our booth. And then we just deploy like what you'll be doing on Ethereum. And that's the most ideal situation. So yeah, we are all in a healthy competition, and all we want to do is make Ethereum a better place. Yeah, so summary about today. Hey, we don't want to care too much about contract migration, and Squirrel will do it for us because we abstract the proving part in the underlying layer. And B, you don't have to trust us. By trust, I mean the Squirrel L2 is down someday. You can be damn sure that you can call some emergency exit function in L1 so that everything there is being out your funds are safe because it's in the layer 1 contract. And 3, for any of the layer 2 solutions here, they are all cheaper than mainnet. So yeah, that's the main thing. You are free to experiment and do whatever you like on it. Maybe it was impossible on the mainnet, but now it is possible on layer 2. So yeah, I hope you, after today, you all understand what L2 is and you will not be confused by all the buzzwords. So yeah, thank you. So yeah, maybe 10 more, thanks for, okay. Maybe 30 more seconds for you to scroll this, scan this and enter our Telegram. Thank you, Bob, thank you, 1inch for shortening your speech so I get so much time. Sorry and thanks. Yeah, please join us.
Thank you, Zari, for your special speech. So this is all for our morning session, and we will be back with even more exciting topics after our lunch break. Our team will guide you through the long of the playlist, where you can enjoy the food and beverage, as well as many games that we prepared. Stay tuned for the afternoon session, and remember the afternoon session will be start at 2 p.m.
Whether that's the amount of tokens that are needed to complete a vote and make it passable, or some like minimum decentralization, meaning how many people are involved. We need X amount of people. If those people don't show up, it's not a legitimate vote. We run into those issues pretty frequently. Contrarian decision making isn't incentivized either. So if maybe you've got a boss who's voting one way, or you've got somebody who you find really influential, somebody who's a mentor maybe, and maybe you disagree with them and you don't want to disagree with them publicly. Right now, there's no privacy on tools like Snapshot. Not that I'm aware of. Maybe there's a plugin or strategy that you can put into place. But majority agreement typically happens. People will vote the way that others vote because they don't want to be seen as contrarian. There's no incentive for really doing that. It can be slow to make decisions in comparison to small teams who are making, a startup, for example, going lean. They might be able to respond much more quickly to crisis. Governance attacks where individuals or groups can take over a treasury and drain all the funds, basically destroying the organization. These things are certainly a possibility in an attack vector. Information asymmetry, people closer to the core of an organization may have more information than those at the edges. So at BitDAO we have 19,000 token holders, and then we've got a handful of partners, and we've got people who, our delegation process is permissionless, meaning anybody can do it, can delegate and take part in this process, but they may have more or less information around a particular proposal depending on whether they were involved or not. And this is with any DAO, this is with any organization, be it Web3 or not. Information asymmetry exists, and people may have trouble understanding how decision impacts them. Fragmentation across platforms is major. I'm sure you've seen the number of DAO tools, which are all, to a certain extent, amazing. The people are developing these new ways of operating organizations. But what happens is that, people will have a discussion on one platform. They'll share comments and updates on a proposal on another platform. Voting takes place in another, and then it starts to stack up, and the experience gets pretty fragmented. Noisy conversations. We're all aware that there's tons of token holders who are incentivized by different things, and because the space is permissionless, we might have short-term thinking overcoming long-term thinking and discussions, and creating a really noisy space where it's hard to improve proposals and ideate together. So just a quick overview there on some of those problems. quick note about automation, this A in DAOs. So where we're at today, and again, up until the point that all decisions are made by robots, or the majority of decisions are made by robots, we will need human coordination and communication. This is like ideation and decision making. How do we build up an idea and then decide how to improve it, and then from there, how do we make changes to that? The execution part can, to a certain extent, be automated by code, and this human coordination and communication piece can also be enhanced by code, but I don't think there's anybody out there really pushing for full automation of human decision making. So let's just keep that top of mind as we continue to move out. What really matters is how do we increase the trust in DAOs. So if we are, by one example, internet native organizations, and you and I don't know each other, but we're taking part in this DAO, how can you assure me that you're a trustworthy person? This is where code comes in and things like smart contracts. I'm sure many of you are already aware of all of this. But happy to discuss further if needed. Okay, so types of DAOs. So each DAO, as I mentioned, is motivated by its own sort of core mission, its principles, its values. And these could be communities, protocols, funds, meaning investment funds, which is what BitDAO is, media, social impact, gaming, and services. And these can all be related to each other. So like, for example, a community that's rallying around an artist who creates NFTs could eventually spin out or become a gaming community that uses the IP that's underlying that NFT to become a gaming DAO that votes on how that IP is used within a game. So basically, each one will make their own trade-offs based on their goals, products, services, their target users, target governance participants, the resources that they have available, and the tools that they're using or that are available to them. Let's see, so governance. Why governance and what is it? To keep this relatively simple, I like, again, to break it down into this simple process of ideation, decision-making, which is discussion or decision-making, and execution. So just super simple, this is a sort of dumbing down, but I think it's instructive for this hackathon. And three important elements that I like to think about in DAO governance are the pace of governance. So basically, how quickly can decisions be made, and when are they made, what's governable, what actually needs to touch the process, and the scale of process, and how do you measure that. So for pace, you might have a crisis that comes up. How do you deal with a crisis that needs to be solved now? If your process is too slow, you have these rigid controls, discussion for 1 week, voting for 1 week. It might take you 2 weeks to solve this crisis that needs to be solved in 1 hour. Next is what decisions are governable. Does every little decision, if you need to update a logo on a third-party website, does that need to go through a vote? Or are we just voting on how we allocate funds from the treasury and how we update governance parameters for our particular DAO? What decisions need to touch the process is a super important one. And then the scale of governance and how it's measured. So small, medium, large, simple way to break it down, but what do we measure? Could be value, time, or commitment. So are we voting on allocating $1,000 or $100 billion? That's a sort of value scale. Time, are we committed to this decision for 1 day? Do we just need to submit a pull request and correct some bug in the next 2 hours, or are we, do we have a whole team working on this for the next 3 years? And that also touches on this commitment scale. Do we have tons of people working on this for years or minutes? Cool. One other quick thing to point out here too is that like this D in DAOs, this decentralization element, governance is really how DAOs drift further into this decentralized world of operation. So governance is used to get more people in the room voting and discussing. Oops. So here's a quick framework. Somewhat quick. This is not all inclusive, just like everything else here, but it's just a way to think about it, to break it down into more simple terms so we can see a high level image of what we're gamifying here. So again, what type of DAO is being governed? Could be any of these or another type. What is the core purpose? This could be a business or community goal. It could be as simple as making money, building relationships, having a positive impact in for example, social impact DAOs, creating an experience, maybe in the sense of an NFT community or gaming community. And then next is where does the governance process take place? Again, breaking this down into 3 phases: ideation, discussion, and voting, and talking specifically here at number 3 about what tools are being used. How are votes cast? This could be on or off chain, gated or public, formal or informal. Informal could be something like Discord emoji votes. Formal could be totally on-chain token voting. Are we leveraging things like coins or NFTs, tokens? How we'd like to define those. And this is another important piece in number 5, relates back to number 2 here. So describe your preferred governance participants. And realistically, these preferred participants need to be aligned with the core purpose of the DAO. They need to be motivated by the mission. But these preferred participants might be product users, subject matter experts, artists in the case of like an NFT community, could be in the case of something like an influencer, DAO, it could be an audience. It could be the people who are bought in to the content that this person is making. And these are sort of core motivations that drive humans in general. These apply to everybody, everywhere. We all experience these to a certain extent when we're making decisions. We all want social influence to a certain degree in certain situations. We all value scarcity in different situations. But I think it's interesting to sort of look at your preferred governance participants and think about where they might be influenced the most, what core drives drive them to create an impact in your organization. Moving on is, where do these participants have the most impact within the governance process? So again, if you've got product users, or a bunch of artists, do we really want them ideating on how to run a protocol? Or a bunch where we've got 100,000 token holders? Are they really the ones to make a technical decision in building a proposal that will later be executed and manage user funds? Thinking about where each of these preferred users have the highest impact, and it can be all of them, that's fine, but just imagining where they plug in is I think, important when we think about poking at these core motivations to gamify their experience, to influence them to take some action. Now, what crypto capabilities or parameters are we using? Is it on-chain data, tokens, digital ownership, in the sense of NFTs or other objects? Smart contracts, identity, reputation, credentials, and broadly, is it just ownership? Is it the sense of having a wallet and owning your whatever's in there, whatever it might be? And finally, what resources can we offer as a DAO, as incentives? These can be financial, such as tokens. These can be sort of scarcity-based things like access and time to a team or an event or an online space. Credentials, again, something that a user can own and take somewhere else. Or can we give them some social influence somewhere in the DAO or in the broader Web3 space or in the world in general? All right, so let's jump into gamification. I hope that was a good primer for y'all on what DAOs are, how I'm sort of thinking about how I'm approaching this. And again, this is, there's no limiting factor here. Please express your own opinion and your own creativity in what you create for this hackathon. So what is gamification? This section, I'm going to rely heavily on the work of Yukai Chow, who's a gamification expert and behavioral design consultant. And I'll just use his definition here, gamification. So gamification is design that places the most emphasis on human motivation in the process. In essence, it's a human-focused design as opposed to a function-focused design. So how I like to think about it in very simple terms is, how do we make people actually enjoy doing the work or contributing productively to some outcome? So, rather than assuming that people are just going to show up and do the thing that they're supposed to do, that needs to be done, we need to motivate them based on these sort of core drives, core human drives, to get them to sort of enjoy the process, really. So why gamify governance in the first place? And my answer is that gamification allows us to be intentional and specific. So we can increase turnout, we can incentivize good decision making, and we can incentivize these preferred participants. Again, being intentional, being specific about who's involved and where they're involved, can lead to greater outcomes. Remember, our goal is to make better decisions as an organization when we're a DAO. And we can use gamified elements to make this happen. And for example, we may want to dissuade, we can use gamified elements to even dissuade others to not take part in a particular part of a process. Though I don't have many examples of how this might work, to be honest with you. But for example, a technical contributor might have different games that incentivize them than everyday token holders. There might be certain things that influence them that your everyday token holder, particularly those who are just speculating, wouldn't be necessarily incentivized by. And one important piece here in the DAO space, and in the Web3 space in particular, is expanding token utility. So how can we make the token more useful, is one question we might ask when gamifying. If the token utility drives value for the token, in the sense that people want to use it more to interact with these gamified experiences, then it could have a positive impact on the project overall. So this is a lever we can pull on. All right, so let's jump into some of these core drives. So core drive, this is again from Yukai Chow. This is his Octalysis framework. Full credit to Yukai Chow. Highly recommend anybody who's interested in this topic to go check out his offerings over his website, and free resources as well. There's some great stuff over there for thinking deeply about this. But in the middle here are the core drives. Number 1, epic meaning, empowerment, social influence, unpredictability, avoidance, scarcity, ownership, and accomplishment. These are all things we all experience in our life. And these are things that drive us to take particular actions and things that motivate us to just make certain trade-offs, really. These are used throughout the crypto space already in the broader market, but also within particular products and projects. So epic meaning, this relates directly to this core values and principle in DAOs or Web3 projects, but in particular with NFT projects, we see this element of lore So the people who are bought into the underlying belief that what you're doing is good or it's interesting, then this is where they get their sense of epic meaning, and where they might start doing the thing for the sake of just doing it because they like it. They like what's going on over there. Empowerment. I won't go into details for every single one of these. There's a handful of examples here on the outsides about how you might implement or create triggers to trigger these core motivations. There's different elements you might use here, from UI features to just sort of social pieces to get people to feel these certain things and make certain actions. But there's a handful of these, like scarcity and ownership, which are inherent in a lot of Web3 products and projects. I think one of the number one most active proposals across a lot of DAOs is like, can we burn the token? Can we limit the supply? Can we make this thing deflation? We hear a lot of talk about this. This is pushing on this core drive of scarcity. People want to increase the value of the value of the thing is expected to increase as it becomes more scarce. This is just sort of core human drive. People want it, the less there is of it, typically, at least for something that's in demand. Ownership, again, wallets are another core piece of this, and it's a core part of why people are involved in this space. But there's, as I mentioned, there's a lot of different elements that you can implement into a gamified experience here on the edge. I'm happy to discuss these with anybody. Some of the key ones that you see across Web 2 and Web 3 products are things like leaderboards, progress bars. So if you're signing up on like LinkedIn and Facebook, I believe there's a progress bar, and they really do drive results. People want to complete those progress bars. They want to get finished with the task, and it is a strange incentive.
Okay, thank Mr. Brian for your online presentation. So in the next part, we'll hear more about funding grassroots developer communities and public good builders on Ethereum, guided by Mr. George from DoraHex. A warm welcome for our speaker in the stage.
It's like just showing this part.
Quay lại cái vừa nãy. Can you send the slides to
I did.
Can you use the laptop right there and you use the cue to the next slide?
Yeah, I sent the slides over.
You send the slides for to please send the slide to this one. is a PDF file, right?
Yeah.
Do you have a PowerPoint?
No, only PDF.
Only PDF.
You don't PDF doesn't work?
PDF does can show and then use this to scroll. So can you put the laptop later?
Sure.
Cool. Thanks, guys. So I just do from here. How do I move? USB-C. I could just do it from here. It's okay. Hey. I could just start it from here. Yeah, that's fine. All right. Cool. Well, sure. I can stand up. All right. Well, hope everyone's good time. Sorry for the technical difficulties. I'm here to talk about Hyperlane, what we call it interchain highway. And so, if you are interested in building multi-chain applications, maybe go give it a listen. So you could ask yourself, what is the interchain highway? What is the state of blockchain state today? We're basically living in a world where we have these really cool, valuable states, but they're all on very different blockchains, and they're all super isolated. So we have like Ethereum, Polygon, Arbitrum, Optimism, all these different chains, but they're super isolated, so they might as well be in different galaxies. And so when you deploy, let's say, your application that you're building on here today, you have to decide like which blockchain do you deploy this on, right? And that choice of blockchain has like huge ramifications for your application. It decides what users can access your application, it decides which liquidity can access your applications, it also decides what other protocols can you compose with. And so we believe that that's just not the end state, like that's just not going to be how crypto scales. And so the question is, what is the end state? We believe we've gone through several different eras of interoperability. So we first started in 2016 when like Cosmos and Polkadot had their kind of like intellectual, I guess, start, where interoperability happens within a very set structure, right? So IBC and XMCP all work when you are able to run light clients that kind of understand natively the consensus of the other chains. However, 2020 came about, and there's this explosion of alternate layer ones, and with that came the need to be interoperable between very heterogeneous chains, right? So like Avalanche, Polygon, all of these things needed to be interoperable, and so we came up with this, what we call asset-centric interoperability, where users had to figure out how do you move from chain A to chain B. And so that's what most people associate bridges today, is basically user figuring out, okay, how do I get ETH from Ethereum over to Matic on Polygon? However, this requires users to interact with infrastructure, and I think if we've learned anything from the last like 30 years of building digital products, and so we believe 2022 will be the start of the era of app-centric interoperability, where interoperability actually gets moved to the application, the developer. And so that allows you as an application developer to basically like internalize the trade-off of like how do you move state from one chain to another, and remove that burden from the user. And so I think that category is still undefined, but like this year was the first year where people started to realize that. And so Hyperlane is what we call the road to that interchain and singularity, right? Where blockchains and applications are all connected with each other, where you have to provide this kind of super seamless user experience where users don't have to interact with infrastructure. And so this avoids kind of this like, oh, like Aptos coming around and solving all of our blockchain problems. Like no single blockchain will solve our blockchain problems. It will be this like large internet of blockchains. And so Hyperlane is the network between those blockchains. Okay, so how does Hyperlane work? Hyperlane ultimately is a set of smart contracts that you as a developer can use to send a message from an origin chain to a destination chain. So the core is very simple. You as the sender call our mailbox smart contract with the dispatch function. The mailbox basically is an incremental Merkle tree on chain. And so once you added your message to that Merkle tree via calling the dispatch, validators will sign the root of that Merkle tree, which allows that tree to be relayed to the mailbox on the destination chain, and then that mailbox will call handle on the recipient contract. And so conceptually, it's pretty simple, and the API looks like this. So on the mailbox, you call dispatch with the destination chain ID, the recipient, so like the address on the destination chain, and then the message, which is just arbitrary message bytes. Note that in this case, the recipient is not an address type, but the bytes 32, because while we are currently only supporting the VM, other chain environments may have not just 20 bytes for an address identifier. And on the destination chain, your recipient just needs to implement this interface called handle, and that handle function gets called with 3 arguments. The origin chain, which again is just the ID of the chain, the sender, just the entity calling dispatch on the origin chain, and then the message itself. You can use our message explorer to basically then track the progress of a particular message going from one chain to another, and get links to the equivalent block explorers of those chains as well. Normally I would show you a demo here, but I'm just going to keep going. So at the base, that's any interoperability protocol, right? Like the passing of arbitrary message bytes. But what we realized is that a lot of times people actually, people always want to do more than just send arbitrary bytes. And so the message API is very much unopinionated in the sense that you can send anything you want. But oftentimes applications have like very specific things that they want to do, and developers would have to kind of specify that themselves in terms of like how to structure basically intent. And so common things like ownership, we can basically abstract away in what we call interchain accounts. So basically interchain accounts allow smart contracts to securely control an account on another blockchain. And so think of it basically as like a custom proxy account for a particular sender on origin chain. And that proxy account will basically make arbitrary calls as defined by the owner on the origin chain. So it's a slightly more complicated than the original messaging API, but basically you still call dispatch on an Hyperlane contract. That Hyperlane contract will serialize your call onto the messaging API, will relay that to the destination chain. The Hyperlane contract will basically relay that call to that custom ICA, which basically acts as a proxy of the sender. And then the ICA will make that specified call as specified by the sender. And so the really cool thing here is that the origin chain interface looks very the same, right? You can call dispatch, the destination chain, the recipient, and then the data, which is just like the ABI encoded function calls. But then on the destination chain, you have to have no Hyperlane specific contract, because the ICA just makes that function call for you. And so that allows, I think, developers to build these kind of cross-chain interactions without even much less surface area. Again, we normally have a demo, but I'll keep going. The next kind of API that we have is interchain queries. So again, normally you could totally build this yourself, but we realize that oftentimes developers, what they want to do is on an origin chain, just be able to read state on a destination chain. And so we have a very simple API for that as well. You call query on the Hyperlane contract with the call that you want to make on the destination chain, as well as a callback that will be called on the origin chain with the result of that remote view call. And so, yeah, you can see this here. I'm going to speed up a little forward. On the origin chain, you once again have this very simple interface. You have a destination chain, the target on the destination chain, the ABI encoded a view call, and then the callback. And once again, on the destination chain, you have to have no surface area. We'll do a demo, we'll do it later if you want. And then the last API that we can present is the liquidity layer API. So message API only sends data, it does not send value. There's a whole topic that I'm happy to go into. Find me offline if you care about basically the question of canonical versus wrap tokens. The Hyperlink's liquidity layer is basically a unified interface that will allow you to use multiple value bridges, like the recently announced Circle's native USDC bridge. So the interface is it's basically the same as the messaging API. You have the dispatch function, and you have 3 added arguments: the token address, the amount that you want to transfer, and then the bridge identifier. So like in this case, it would be Circle or Portal. And on the destination chain, you have exactly the same handle interface, except you also get the token address and the amount. And again, we'll skip over the API demo. All of this happens in 5 minutes. You can go into our docs, and you can just do it yourself with MetaMask. It's very simple. All right, I think everyone's busy here, but if you have any questions, come find me. I'll also be at the booth. And yeah, like definitely can contact me. I'm at hyperlane.xyz or on Twitter, or come check out our docs on docs.hyperlane.xyz. Cool, I think that's it. Yeah, happy hacking.
Thank you so much, Mr. Chu Hainam, for your very detailed. So we will take a break for about 10 minutes.
Okay, so the goal today is to hope you know what makes rollup different and know what account abstraction is about. Okay, so layer 2 solutions and rollup. What is layer 2 solutions? So layer 1, we have a block space, which is a really scarce resource, so it's very expensive. So the idea of layer 2 is to move the execution and data off chain of layer 1, and we only submit the result of the execution on chain. So that's why layer 2 is fast and cheap. And what are those rollups? What are layer 2s? We have many layer 2 solutions. There are many, but here I will only mention 3 of them. The first one being sidechain, second one Plasma, and the last one is the rollup. Okay, so what's the difference between sidechain and Plasma? Sidechain is run by operators, and you enter and exit the sidechain with operators' permission. For Plasma, it's also run by operators, but now you enter and exit Plasma via a smart contract. So the rule to enter and exit is written in smart contract instead of full permission from the operator. And so in Plasma, operator will periodically submit state rule on chain, and you will exit the Plasma by providing proof. This could be like Merkle proof to prove that you own $100 on the rollup, or on the plasma, sorry. And you also can challenge invalid access. So what's the downside of sidechain? The problem is that you can only trust the operators, which is a big problem. For Plasma, you still need to trust the operators, but only to a certain degree. The operator, however, cannot just take away your money. So what's the difference between Plasma and rollup? In Plasma, operator can censor your transactions. Operator can withhold transaction data so that you cannot verify correctness of state root. In rollup, just like Plasma, but all the transaction data are submitted on chain. So you can verify the correctness of the state root. And you also can challenge invalid state and prove state valid. So the problem of Plasma, as we mentioned, is that you still need to trust operator to some certain degree, but the operator cannot just take away your money. For rollup, operator cannot do any damage but to degrade a system performance by providing a shitty service and then going vote it out, which is really nice. Okay, so a recap on rollup. All the data will be made public, and so everyone can compute and verify the state himself. And in rollup, it can also guarantee the state validity via two approaches. The first approach is by fraud proof or fault proof. So you will use a proof to challenge invalid state. The rollup that does this approach is called optimistic rollup. And the second approach is the validity proof, where you prove your state is valid by providing a zero knowledge proof. And this kind of rollup we will call validity rollup, which is also known as ZK rollup. So what's so important about rollup is that it shares the same levels of security as layer 1. And you can build different VMs on rollups. It doesn't have to be EVM. You can build every VM on you can possibly imagine on rollup. So the catch is that you should definitely build a rollup instead of another layer 1, because your rollup is as secure as layer 1. For example, Ethereum, where it's secured by billions of dollars on layer 1. And besides its security, it's also way faster and cheaper than layer 1. Yep, so that's the introduction of layer 2 solutions and rollup. Now we'll have a quick overview of the current rollups. For optimistic rollup, there's a problem, which is the challenge period, and it's currently 7 days for both Arbitrum and Optimism. And so it's a bad user experience, so you have to have third-party bridges to help improve this problem. For example, Hop, Orbiter, or MakerDAI bridge. You shorten the period so that user doesn't have to wait 7 days to get their funds back to layer 1. And ideally, this challenge period can be made adjustable according to how congested the layer 1 is at the moment. For validity rollup, currently the problem is that the proof generation is very slow, but don't worry, we have recursive proof to improve the speed and reduce the cost. For rollup in general, the problem would be that submitting data on chain is and or will be the major cost to rollup. And so some rollup may choose not to submitting data on chain. For example, if you do this in optimistic rollup, if the data becomes unavailable, users will lose their fund, which is quite a problem. And rollup, live example of this kind of rollup is Nova. And if you're a validity rollup and you want to not submitting the data on chain, and if the data becomes unavailable, users' fund will get stuck. And the example of validity rollup doing this is the Starwest Validium and ZK Porter from ZK Sync. Okay, so what else can we do to reduce the data cost? For rollup itself, you can apply the data compression algorithm on the data. And for layer 1, it can help by implementing these two approaches. The first one is the EIP 4844. It's also called pro downsharding. And next one is the real big deal, the downsharding, which would dramatically cut down the data cost. Okay, so anyway, you should check out the l2b.com. This website is awesome. It has layer 2 data like TVLO, and also has security overviews for different rollouts. So anyway, a rollout is very awesome. So build on rollout instead of building another layer one. Okay, so next topic is the account abstraction. So now, what we are we have like when a node receives a new transaction, it will check the sender nonce and the sender signature. And nonce is used to determine the transaction ordering, and signature determines how transaction is authorized. And these rules are hard-coded at the protocol layer at the moment, so there is actually no flexibility. And that's the problem. So what account abstraction is doing is to abstract away how your transactions are ordered and also how you authorize the transaction. And so in account abstraction, you can customize these logics in your contract instead. For example, you can have parallel transactions for transfer, or swap, or loan, or other DeFi's operations. You can you can have a queue of nonces for each action or each category of these operations. And you can also have your own customized signature schemes, for example, RSA, or using an aggregated signature like BLS, or use a ZK-friendly signature scheme, or post-quantum secure signature schemes. Anyway, you are a contract, so you're not just a pair of keys anymore. You can do so much more than just a pair of keys. You can implement any logic you want. So since everyone is a contract, so you definitely include the benefits of contract wallet. Like Gnosis, for example, the benefit includes multi-calls, where you can do approve, swap, deposit, stake, all just in one single transaction. And you can also do social recovery, and it's an additional helper to combat your private key loss, private key theft, or any other constant logics you can think of. But there's also definitely drawbacks and challenge to account abstraction. The first one being the DOS attack risk, because now the node need to actually execute the transaction to find out if the validation passed or if the contract has enough to pay for the gas fee. And another downside is that it will bring a drastic change to the protocol. And talking about this problem, we have ERP 293A, where it poses drastic protocol change. But in another EIP 4337, it doesn't bring any protocol change to account abstraction. It's purely account abstraction on the application layer. So a little bit about the EIP 4337. So there's mainly one important thing, is that instead of a transaction, Ethereum transaction, we have user operation instead. It's just like a normal Ethereum transaction where you can do simple transfer, you can do element swap, you can do DeFi ops, etc. Just like a normal Ethereum transaction, but instead it's in another format. And you, for example, you want to transfer Ether, you will you will craft your own user operation, like filling in who you are, how much you want to send to who. And then the bundlers will bundle user operations and send this batch of user operations to miner. And so users will pay the bundlers from the user's contract in ETH or other ERC20 tokens instead, which is nice. So in account abstraction, what's the difference to what would the user experience look like in account abstraction? So first, your identity on chain is a contract instead of your public key. And key pair of mnemonic works is no longer an essential part in this design. So, and also you will be able to use mobile or other common device to sign transactions securely instead of trusting another wallet app. Okay. Cool. Final part, account abstraction on rollout. So rollout actually has great incentives to adopt account abstraction, since it has little better compatibility problem for them because they are really new. And especially for validity rollout, where you implement less features in the protocol, means you get more flexibility. So there are currently 2 validity robots that has implemented account abstraction on them. The first one being StarNet, and the second one is zk-sync. So today I will only cover StarNet. So in StarNet, the transaction authorization is abstracted away. It means you can implement different signature schemes or other transaction authorization scheme in your contract. But the nonce is not abstracted away for maybe simplicity reason. And also to mention in the past, since StarNet has ECD as a algorithm over star curve instead of the Ethereum curve, which is SECP 2x6K1. So that means in the past, we don't have Ethereum wallet support, like Untoken or MetaMask cannot support account abstraction on StarNet because they don't use the same curve as Ethereum. So then we have different companies building StarNet specific wallet like RGNX, Bravos, and MetaMask Snaps. But now the software team has built a library specifically for SECP 256K1 over ECDSA, and they also built the KCHA, and now so actually the Ethereum wallet can support the StarNet account abstraction now. So in StarNet, there are a few problems, like every user must deploy his account contract first, and that address must first have some Ether to deploy it. So which is kind of a problem because you haven't deployed the contract yet, but you have to have the Ether first. We can solve it. Maybe the deployer can cover the cost, like the wallet can cover the deployment cost and maybe charge the user later. That's one approach. But anyway, so in account abstraction, there is no more import private key than go because private key is not tied to a certain address right now. Only the contract is, so we can no longer do this easy import private key or export private key approach. Some problems currently in the StarNet I would like to mention is that they don't have a gas price option for you to prioritize your transaction, but it's not air related. So the second problem is that it doesn't yet support user paying fee in ERC20. There's also the benefits to account abstraction, just like I mentioned. First one being the multi-core, where you can have multi-actions done in just one single transaction. And second one is the social recovery. Third one is the really nice features called plugins. And here I will have an example called session key. So session key is a key with more fine-grained capabilities. Maybe when you use session keys, you doesn't use your private key to sign many things over a duration of your dApp usage. Instead, you have create a session key just for this specific dApp, and you can specify capabilities.
Hi guys. So I don't want to bore you with a presentation and tell about my software, how it works, how it is changing the world, and why it is the need of the hour. But I really want you to actually experience how we have created this product, because we really don't believe in big slides and not user usability. My name is Prakash Pathak, and the product is Ferron, right? And it's a Web3 aggregation layer, and it's built for developers, right? As developers, we feel, because I'm a developer myself, and as developers, we feel that there is a whole lot of learning curve when there are multiple chains and multiple technologies involved while using blockchain. So we came up with this problem like that there are multiple levels of operations and multiple levels of CLI required to just put your dApp onto the chain. So we kind of changed it, and we made a no-code tool, and it's very easy to use. So are you guys building right now? Yes? Yes? Okay, so can I know the framework which you are building right now? Like, Are you using JavaScript? Are you using Rust? Solidity? People who are using Rust or Solidity, can you raise your hand? Okay, I can see one. People who are using JavaScript frameworks, can you raise your hand? Okay, that's good. And what else people are using? Okay, so so whatever you are actually using, are you aware of IPFS? Right? So IPFS is a file storage system, right? And for that to be actually leveraged, what we did is, can you just open a tab? Can you just move from your VS Code and you can just open Chrome and open Spheron.network? I don't want you to actually, I really want you to actually use the product versus me telling you whole about it, how it is, what it is for. So you can just, right now you can actually open your Chrome, Safari, Brave, or whatever you are using, and you can open Spheron.network, right? Spheron.network really helps you to put your front end and compute on blockchain. And in very easy steps. Like, we faced the same issue years back, and we have been into the space for the past 4 hours. And it's an easy deployment tool. And we don't want to, we really want to bridge between Web 2 and Web 3. This is what we are really behind. And actually for Web 2 users, to create a usability for them, right? Create accessibility for people to actually host on IPFS, Pinata, and Arweave and Skynet, right? So that's what we provide deployment for both your front end and back end. So for your back end, I think you're aware of MongoDB, Redis, Postgres, multiple types of back end people use in this. And we help you to compute that. And it's, I feel the product itself speaks for itself. Like, the product is so simple and so straightforward that you can just open Spheron and you can start a new cluster and you can start with your backend and also with your front end itself. So it's quite easy to use, it's quite easy to leverage. And the reason we have built this, or the reason we have Spheron, is just to bridge between Web 2 and Web 3 and also enable developers where you need a tool like this so that you ship your dApps very easily, right? So the usability for Spheron is quite broad in comparison to other tools out there. And as you can see that, how many of you are actually working in Web3 space? Like you, okay, I can see one. The rest of the people, are you working in Web3 space? You're working in software space, right? So see, mostly the software space gets created and there is a whole lot of money involved in DevOps team. I feel that you are aware of what DevOps is, and DevOps requires a whole lot of crunch when you are actually building a small project for yourself and you're pre-revenue and you want to ship to business very fast, and there is a whole next level of things required while you have to build a DevOps team for your project, right? We kind of save you from that. And we save you because these tools make it leverageable. You can leverage multiple chain, and we're chain agnostic. So that makes your project chain agnostic as well. So you want to put your front end on Filecoin? Yes, you can do that. You want to store your DB using Postgres? Yes, you can do that. You can create a cluster and you can create an instance. So you don't need the complete cycle of learning, for example, Akash, right? So we are aggregating over multiple networks so that you can use them easily. And where we come into play is that you can actually run your IPFS node, APIs, node, packages, anything you want to. So it's very flexible at what do you really need the product or the tool to actually do. Right now, I think most of you would be creating a dApp, or like you would be creating something where you are leveraging EVM. So this is something which you can really give a try to, and you can really understand why we are trying to solve this problem. Because as you can see that there are multiple dApps around and DEXs around which have their front ends based on AWS, and that doesn't makes it truly decentralized. And as you can see that there in most of the times when you see that there are front end getting compromised. Like when you see that there is some kind of hack or involved, there are multiple front end private keys and public keys that gets exposed, and which leads to a loss of so much money. So that's why we thought that hosting is one of the biggest problem that we're trying to solve. We are scaling very fast in India. Like we have onboarded around 2,700 tabs with us in India, and now we are in Southeast Asian market. And we're also hiring at this point of time because we are aggressively looking at different markets and different streams itself. So feel free to reach out to me on Twitter, Telegram, or Discord. Now, how do you actually do that? So it's quite simple, and I feel if I still have 1% of your attention, you go to Spheron.network and you click on deploy now. And that's it. That's where it takes you. It's a 3-step thing, and you can just do it within 2 minutes. So we really value time on blockchain itself, and we have our own CDN network, and also we do DDoS mitigation. So to make sure that it's quite fast and it's quite secure. Now, most of our features are very straightforward. You can do multiple protocol deployment. You can use the CDN, and also we are upgrading our features as we speak. So we are like, our company is developer first company. So we have the tools or the features we actually involve in development are actually built on the community's mindset itself. For example, we do take community very seriously, and we do take support very seriously, because these are the things which makes a project great. I'm just not speaking in the perspective of Web 2 or Web 3. This is how simple projects go from good to great. And we also do DDoS mitigation, and we have a validation tool as well. So that validation tools really provide you that this DEX or this DeFi or this exchange is safe to actually put your money in, right? Because we have seen so many failures, and we have seen so many downrights because there is transactional element involved in this, and that needs to be completely secure. And for that security and also scalable, because if you make it downright secure and it's not scalable, it would be a very big issue for any dApp developer out there. So it's secure, and you have also CI/CD pipeline, which I feel is very important in a dev cycle too. And you can attach your domain, and you can do a whole lot of things. And the billing is very flexible. Right now we are working on fiat payments, but we are flexible with crypto payments right now, and we have built a solution for that. These are some ecosystem partners what we have, and I think some of the infrastructure partners, ecosystem partners, and we have some clients right now. So we are already into business, and there are people who are already using us, and we have onboarded few of the Web 2 clients too, for them to make them understand why they really need a decentralized compute, or why do they really need a decentralized infra. And that's it. And if you have any questions, right now what I'm going to do, built on. And all you need to do is just, if you have any environment variables, just select those environment variables and just click on deploy. And that's it. We have a running bounty in Buildathon, as you can check out on ETHVIETNAM team, and it's quite simple to actually win. And right now, this is quite a heavy front end. Like, it's not a light UI, but the amount of time you would see that, because we are already on mainnet, so it takes less amount of time to actually initiate and get started with it. So so I think this is the time. I hope it does not break. I'm kidding. So. Okay, now once we do it, it's quite simple. You would get a IPFS link and a hash to the web front end where it has been hosted. So Ta-da. So you can preview the deployment over here. You would get a Spheron.app link in here. And this is a quite heavy front end which we created. So you can, like, I kind of like this. And as you can see that you have this Spheron.app link with it, and also the IPFS link over here. And you can preview your deployment. You can see where it has been based on. You can actually attach domains to it too. So if you have any domain, subdomain, and if there are, like, if you want to attach domain to the same, you can do that. And you can add teammates to it. And also, like, something I want to, like, really focus upon is dark mode. So, like, it's the best. Okay. So we have for this we have compute 2, and compute 2 is something which we really take pride in, because you can basically start with your Docker image, you can import it from Docker Hub, or you can select a template from over here. So really it really saves you from the pain of really understanding. If in this scenario it's akash.network, and you can go to akash.network and you can select that there are multiple, it has a learning curve to it. So we have been good friends with Akash, and we are built on top of aggregation layer on top of akash.network. I hope my presentation was clear, and I am a technical person myself, so I really am not a fan of big slides, big pitch deck, and I really feel that there should be more of hands-on approach while doing it. So thank you so much, guys, and best of luck for building, and I hope you build something great. Thank you so much.
Thank you so much for your presentation and the practice, Mr. Pathak. And now allow me to introduce Mr. Neil Han, founder and CEO of Radio. Welcome on stage, Mr. Neil.
để check lại.
Hello everyone, very good afternoon. I know you guys has been building and tired. I'm trying to make this one very quick so that you guys can come back and focus on building. So I'm Neil, I'm the founder and the CEO of Radio. So we are the company building the infrastructure for Web3, focusing on scaling on Ethereum network. Today I'm going to talk about some of the issues I have came across with the customers and how we really solve it and really deliver the APIs for the developers. When I started Radio about a year ago, I have a lot of customers from APAC coming to me asking me a lot of questions like how can we really work on Web3 applications because Ethereum is slow and the gas fee is expensive. That's where the developers are really has a little bit issues on scaling Ethereum network, and that's where they come to other chains. And the worst or the best part of the scaling on Ethereum is they have to build the mobile platforms, Unity platforms. That's where you have to scale cross platforms, right? But look at when the bear market comes, what happens to all the major NFT transactions, right? That's where you see a lot of NFT has been trading actually on Ethereum network because that's the blockchain really has been really working and has the most attractions across the platform and industry. And scaling for Ethereum. We look into the landscape of Ethereum, look at the EVM compatible blockchains, and also the other layer ones trying to solve the scaling issues for layer one. It didn't really work out until we find this company which is called Stockware, where they can provide 9,000 TPS and also zero gas fee almost, right? But when I look into this, right, my eyes really bright because look at this scaling for Visa and MasterCard. Their transaction per second is actually 20,000 transactions per second. With this technology, basically you can scale your applications decentralized, right? Not really centralized because there are so many issues for centralized exchange and the platforms because they hold your assets. That's not the key for the Web3 and decentralized applications, right? So this is StarX, the technology underneath of Radio, where they handle like last till September this year, they handle 230 million transactions on their platforms. They hold about 700 billion tradings on the platforms. These are the technology pretty much has been really validated for the past 2 years. How the whole technology works, just want to focus a little bit here, right? All your applications, the transactions can really come to Radio APIs, and we bundle like thousands of transactions in one sequencer. With all these sequencer, we are generating a proof at layer 2. all this proof is actually a hash key, right? That's why we are able to compress the data at layer 2. And when it comes to layer 1, it's just a verification of your whole transaction. That's why we are able to lock the security on layer 1, at the same time scale at layer 2. And that's the essence why the StarX technology can really scale to 9,000 transactions per second. And because of aggregating of all these transactions at layer 2, right, we are able to, I'll give you an example. When we do a calculation for NFT minting, 1 billion NFT minting on layer 2, the gas cost is only $50 US, right? So as a platform, we don't want the gas fee to be a burden for developers. That's where we give you 0 gas fee for the minting, right? When you do the minting on layer 2, right, all the NFTs at layer 2, it's a 0 gas fee, including all the transactions. So with this, right, you are able to make all the transactions at layer 2 with 0 gas fee and 9,000 transactions per second speed, which means you can deliver your applications fully decentralized at StarkEX on layer 2. And what Radu built is really a full stack technology for you to build with your programming language you are familiar with. For example, you use PHP, Java, Python. That's what we support at the blockchain interpretation layers with all the NFT APIs, ERC20 APIs, and also order book, so that you can build the NFT buying and selling easily with the APIs, the programming language you are familiar with at layer 2. To make it even easier, we also support JavaScript SDKs and Unity SDKs, where you can build an in-app, in-game experience with our SDKs with only few lines of code for all your NFT logic and token logic. And we observe how developer has been using the technology. They are actually build a lot of in-app, in-game NFT marketplaces or their own experience for the NFTs. That's where we build an open source marketplace. You can just take our source code and build on top of the source code into your own games. So we do observation, the developers, after, definitely we are in the early stage, the documentation, we are still in the middle of enhancing, but as long as they get the basic logic understood, it only take a few days to integrate all the gaming logic with our SDKs. Definitely we want to show you some demo, right? Because by seeing is what really, by doing is what you can really see how easy it is to build the platforms. I'm gonna hold my mic and have a limited capacity for my hand to show you the demo. But these are the platforms. After you click the dashboard, you are able to come to this dashboard. And you just create a new project. Let's call it Builder Zone. And then you create a new project, right? Once you create a new project, that's where you need to bundle, you need to have a smart contract at layer 1, because that's where you can transfer the NFT asset between layer 1 and layer 2. That's where you actually need to prepare a metadata for your smart contract at layer 1, because if you don't have a metadata for NFT, right, we can't really show you the metadata and the NFT images and all those informations. So I prepared some metadata on our server already. If you are doing your own metadata logic, you either store on the centralized service or using the IPFS to really have this API ready and URL ready. So after that, right, what you need to do is, because we have some quick start here, we actually even automate the smart contract deployment. You just click this smart contract deployment. You just choose the ERC 721M and choose your name, builder song, and have some symbol there. What else you need to do is to pull the metadata, the base URL, into the smart contract. So with this simple deployment, right, you are able to basically generate the smart contract on layer 1. So far, you don't need to code anything. We automatically generate the smart contract at layer 1 and bundle all the basic informations into the smart contract. So it will take a little minute to deploy the smart contract because Ethereum is definitely slow as other layer 1 EVM blockchains. Yeah, now you actually have the smart contract. I prepare a little bit cheat sheet to make sure my demo is not broken. But what you need to do is really just keep the smart contract address here, because once you deploy the smart contract, right, you will also be able to see the smart contract at layer 1, right? This is the smart contract we just deployed for you guys. You definitely can do your own smart contract. That's for you to really edit. But we just want to build an easy to use API for you to do it, right? The other thing is we have a demo website where you can take the demo and run after you deploy the smart contract, right? You need to see something, right? So that's where we actually here generated a tool for you to get the start key, because at layer 2 you need to get a start key or layer 2 addresses from the wallet, right? Here I already put the start key layer 2 address here, and what else you need to do is to just bundle the smart contract with the start key, right? After that, it's already ready, guys. You just need to mint the NFT. This is the minting of the NFTs. I just show you as a curl, but we actually support many other different languages like Python, PHP, JavaScript, and all those. So again, I always make the mistake, forgot to bundle the smart contract with my projects. So once I bundle the smart contract addresses, it should be ready to go. Let me give me a second. Let me bundle them together. So then the smart contract should be bundled together already. And now what you need to do is to just run the code. As you can see, the NFT has been minted already. And what you can see from here is in your own wallet, as you can see, you are able to see the builder's own NFT minted at layer 2. This is how fast you are able to build layer 2 NFT APIs. Definitely we are able to do more, right? When you come to our quick start, we show you all the different logics at documentations. For example, you can do NFT transfer with a few lines of code on the JavaScript SDK. You can also do ETH, transferring your ETH from layer 1 to layer 2. After that, you can do all the logic on layer 2. For example, you use ETH or USDT to do the trading in the NFT marketplaces. You can also launch your own token at layer 1. You transfer your token to layer 2. That's how, after that, right, you are able to basically, as you can see, if you want to do like a token transfer, this is our own token. There's no token left, but let's see others, right? You can transfer your, let me see anything else I have. You can transfer your token at the layer 2, 300 milliseconds, right? That's how fast you are able to do in your own game. And hopefully you get some ideas on how ready you can do for your NFTs at layer 2, right? So our customer really take all this quick and simple demo to next level. This is one of the gaming customers. They take our open source sample code, because the demo I show you is actually fully open source. You can always go there and take the source code and read about it. But look at this game, right? It's quality, very well built. They have been building the Web2 game for like 10 years. They take our source code without understanding anything about smart contract, Carol, or Solidity. They are able to do their own in-game NFT marketplace within a few days' time. That's how Radu has been building for game, for Web3 apps, to scale your applications fully decentralized at layer 2. Definitely, developer asking us, you can always do a layer 2, zero gas fee, high transaction. And what happens if you want to launch the NFT in other marketplaces, right? So right now we are working with like MinSquare and NON marketplace for you to trade at layer 2 directly with zero gas fee and high frequency transaction, like almost 10,000 as I mentioned, transaction per second. But if you really want to do something else like OpenSea, that's where you have to move the transaction into the NFT into layer 1. Then you can be listed on OpenSea, right? After that, you can ask or give a button for your gamers to bring the layer 1 assets to layer 2. After that, you are able to scale your NFT logic at layer 2 with all the benefit I just mentioned, right? We are working also with ZK Sync to provide the same experience for your developers so that you guys don't need to struggle on all the terms at the layer 2. You just use it as part of the APIs. In this hackathon, we provide 6,000 bounty. If you guys haven't started yet, you know how easy it is to get it started, right? You can actually start from now to do the NFT minting and some logic at layer 2. We have 6,000 bounty for you to grab. The 6,000 is really nothing. That's where we actually work with accelerator like a Scaling X. They are the accelerator focusing on zero knowledge technologies, right? They are able to help you do the ideation for the product, operations on the business side, and also building some marketing strategies across Southeast Asia if you guys are not only looking to Vietnam market, but also across Southeast Asian market. And they are also helping you for fundraising for sure, right? This is one of our venture partners to help you build on top of radio and the Starknet ecosystems if you guys are interested to move out of the hackathon doing more real world business. This is a partner we can help you guys. Always follow our radio Twitter. You search radio_.com. You are able to find us and ping us if you need any help for Scaling X. Another venture capital can really help you guys is after accelerator program. We have company like MC. They are also partnering with us. They are the top 1 list crypto exchange in terms of the quantity of token being listed. They have their venture capital arm where they invested already 300 plus portfolios from seed until Series B or C round, right? They are our venture partners to help you boost your business from accelerator to next stage. We have booths there. If you guys need any help, I have their name card there. You can come to grab their name card from me. So that's radio, where we build the easy to use APIs. We are not only doing this, right? We are doing more for developers like you guys. We would really like to hear from you about your feedback on our technology. What else APIs you need from our side? We are here to help you guys. We are the ones really listen to developers and trying to build the best developer tools for the market. I'm based in Singapore, has been working for Southeast Asia and APAC market for the past 16 years. I have the connections, and you guys, if you need any help, come to me or to my booth. We can have a talk. Definitely, I want to give you a little bit sneak peek on what we do next, right? Because this only for layer 2 for scaling. What else you can do? This is actually what Starkware has been working on. As you can see, StarX will be at layer 3 very soon. We have the choice, or you have our APIs to choose whether you want to stick the StarX on layer 2 or layer 3. But with this, right, we are able to use the StarNet as a composability layers, so that on this,
a lot of nice properties that you don't necessarily find in other zero-knowledge proof systems. So what it provides integrity. So when people tend to call things zero-knowledge proof, but the reality is that the best name for it is more like validity proof or proof of integrity. So what is integrity? Computational integrity. Computational integrity means the following thing. It means doing the right thing even when no one is watching. So this sentence comes from Carol Lewis from Alice in Wonderland. Repeat after me. Integrity is doing the right thing even when no one is watching. And this is what we actually build blockchain for. How can I trust you when I don't know you? And so the point of this tech is that we can today make those things verifiable. I can make you believe that whatever I did when you were not here was true, was done honestly and efficiently. So why does it matter? It matters because this is what will enable us to scale Ethereum. Today, we are, seeing that the gas price, not today anymore, but like last year, for anyone who was, on the market during transaction at $100 each, during, whenever things crash. We do remember that ETH is scarce. The block space in ETH is scarce. Transactions are expensive and will always be expensive. And so this technology, the zero-knowledge proof, will enable us to maintain the same level of decentralization, the same level of security, without compromising on scale. So, just to give you a few numbers, as I said, we are able today to do more than 10 times cheaper NFT minting, 200 times or 2,000 times cheaper on perpetual trading. No trusted setup, no signing key, no multi-sig, no mind brace to be hacked. And so all of that is what Starkware is enabling. So, I'm going to make a quick dichotomy between Starkware, the company, StarkX, the product, and StarkNet, which is a network. So, Starks, as I said, is the zero-knowledge system. So the way Starks work is it splits the computation, what the miner do, what the validator do, from being, repeated by everyone after him, to having a system where the miner, the sequencer, will spend a bit more time to prove whatever I did, and the verifier, us, running on our phones, will be able to verify instantly. And so Starkware, the company, is a 5 years old company, is made of how many people now? Over 100. We have raised 250 million in equity from various top investors, namely Vitalik, Sequoia, Cotu, you name it. And we have created a lot of new protocol and research that has been used now throughout the industry. And so today, StarkX, the product, what it is. StarkX is what is currently used. The first thing that Starkware came out with, and this is what is currently used by the likes of DYDX, Immutable, Soware, Radio, among others, and more to come. Today, StarkX settled over $800 billion of trade, thanks to mostly DYDX, has minted over 85 million NFTs, as working with actually, Radio's not here, that's a mistake.
Yeah, add it.
I'm running right into the wall now. And we have over $1 billion TVL currently on our various contracts. And so, what is now StarkNet? So, as I said, we're Starkware, the company. There is StarkX, the SaaS platform, the Validium solution that will protect your asset from a bad FTX. If you don't know what I'm talking about, I invite you to read the latest post by Vitalik, Proof of the Reserve. And what is StarkNet? So StarkNet is the first production-ready ZK rollup for where you can write and deploy your smart contract. So on StarkX, you have a general-purpose programming language called Cairo, and you can write your smart contract, deploy them, and you get a couple of things from that. You get cheaper execution, and a lot of savings over time. So what can you do on StarkNet that you can't do anywhere else? So for a dev, from the developer perspective, there is 3 things you're gaining. You are gaining cheap code data. Very concretely, what are you getting when you're using a ZK rollup versus a regular chain? You are gaining, with the same security Ethereum, with alignment with Ethereum, all of that, you're getting cheap code data, meaning you can pass a lot of data from off-chain to on-chain. You can pass metadata for NFT, you can pass Merkle trees, you can pass large signatures, you can pass things like proof of stake verification of various signatures. You have cheap computation. Chip computation means that, I can do like, I don't know, simulation of collision, which people have done. You can make random walks, or you can do like things that are not practically feasible on a regular chain. And the reason is because all of that is compressed by the zero-knowledge proof, by validity. And finally, the last thing that you're getting on StarkNet, which is surprisingly unique to StarkNet, although it could be on any other chain, is something called account abstraction. StarkNet do not have private keys at all. We don't. We have account, and account have, smart contract account, and smart contract have signing keys. So this might seem like a small detail. It actually changed a lot of things. Among what it changed, it enables you to customize the logic at the wallet level. You can do natively things like multi-call. So for instance, this awful approval swap that we all face every time is a thing of the past when you have multi-call. I can chain it together. I can do approval, swap, revoke in one go. I can add logic on top of this. I can do things like creating plugins that are going to put 10% of whatever I'm sending to someone to a setting account. I can do things that are a bit more practical and actually more useful. So StarkNet has quite a large on-chain gaming community. So for those who are not familiar with this, on-chain gaming is the niche of blockchain gaming. On-chain gaming do not only manage the asset on-chain, it also manages the game logic on-chain. So you're not only playing an off-chain game with an off-chain asset, you are playing a on-chain game with on-chain assets. And so the crazy thing when you start doing this is that no one wants to play a game where I need to pull my ledger every 5 seconds to sign any operation I'm doing. It's not going to happen. So account abstraction enables you to do actually fascinating things. It enables you to create keys that are valid for a certain duration and for a certain set of operation, and only for that time period. And so you can have like keys that are less secure for that purpose. For instance, using your Face ID or using the chip that you have on your phone. And that will enable you to play a game without having to think about it twice. And so the example I just gave you, Face ID, is actually an example that the company on StarkNet already has been building. It's called Cartridge. And if you go to cartridge.gg and you just write login, you write your login name, you put your login, you put your sign login, you put your Face ID on your phone, and then they will automatically create a private key that will be secured by the secure enclave of your phone and still enable you to play without having to think forward. So now where do we stand? So this is actually a bit of an old slide. We're way past constellation at this point. We are able to write any arbitrary thing that you would like to deploy on ETH, you can write on StarkNet right now. We are over, these are very old numbers. We are over 1,000 monthly active dev. By monthly active, I mean devs are writing Caro every month, at least once. We're talking about 130 companies building on StarkNet only projects, and we're talking about any raise and seed pre-seed for StarkNet only project, seed pre-seed anywhere between 60 to 120 depending on how you count and who you count it. Basically the question is, do you count Argent or not? Argent being now raised $40 million for their wallet, basically based on the strategy that they're going to be the MetaMask of StarkNet. So now I talked a lot about Caro. So StarkNet, as opposed to regular, other layer 2s that claim or have EVM compatibility, StarkNet is not natively supporting Solidity. Meaning that if you want to write on StarkNet, you need to write using a language called Caro. Yesterday, we just open sourced the newer version of Caro called Caro 1, which is very Rust-like, if not completely Rust. And Caro exists for a couple of reasons. You have to understand something. The way your CPU works and the way your ZKP works is very, very different. Your CPU likes bits and bytes. Your CPU likes Boolean logic. Your CPU do not like division. On the other hand, ZKPs like arithmetic logic. They like addition, subtraction, division, multiplication. And the base element you're going to work with is what we call the field element. So the computing paradigm between what you work in a ZK environment and what you're working in a CPU environment is very, very different. And so the thing that we worked on to optimize for that purpose of performance under those constraints. And that's what we built. That's what we built. We built Cairo, which is actually a steering complete language that enables you to do all the things that you want to do, but in a bit of a different way. And so the reason why we did it this way is that because this tech is so new and so groundbreaking, we want to optimize for performance, for the general purpose of doing things that make sense. And then now what we're seeing is that because this is super simple now, we have company and project building backward compatibility tool. People doing transpiler from Solidity to Cairo, things like Warp. Or we have people like who actually a month and a half ago started a community project, started a month and a half ago, that is wrote an entire ZK VM in Cairo in the space of a month and a half. They didn't completely finish yet. It's called Kakarot. It's been, Vitalik actually put one on the space. We talked about it a couple of times recently. And this is completely community-based. They are missing now, I believe, like maybe 15 opcode, which are mostly like the question about syscalls, all the EVM, all the sort of like very low-level contract deployment kind of thing like this. And they are already able, after a month, to compile an ERC20. In a couple of days, they should be able to compile a 721. And in a week or two from now, hopefully, Uniswap's type of transfer. StarkNet, the way we need to think about it is that StarkNet is an operating system. So StarkNet is the operating system. Cairo is the primary language of that operating system. StarkNet itself is written in Cairo. And what StarkNet does is that it has every contract basically is a program installed into the OS. And every time you are operating on it, you are making a transaction that is provable. And so once in a while, what's going to happen is that the network is going to take your set of transactions, all of them, but creating a big batch and prove them on layer 1. So this makes it very different to other sidechain or L2s. Because when you have a ZK rollup, you have a system that is fully verified, as opposed to Cosmos chain. So just to go beyond the technicality here, the main difference between a Cosmos chain and a ZK rollup is the type of validation you're doing. So a ZK rollup, the Cosmos chain is doing what we call live client verification. So you have to believe that the proof of stake system on the Cosmos chain you're syncing is trustworthy. Sometimes it's true, sometimes it's not. When Luna crashed, all of a sudden the proof of stake system, the thing is that you don't need decentralization anymore for that chain to be trustworthy. And so that's why we're looking at systems now which are centralized but still trustless. Things like Sorare, things from like DYDX, things like Immutable. And so this brings us to basically the latest stage of scaling when it comes to ZK rollup, what we call fractal scale. Now, since I'm able to verify, a rollup on Ethereum, why can't I verify a rollup on StarkNet? And recursively have layer on top of layers on top of layers. And so this is kind of a long-term game of scaling. Whenever someone is going to be priced out of a specific chain, it can go to another layer without changing his code base, just because this chain is cheaper now for him, while keeping the composability, while keeping the infrastructure and all the tooling he built before. So, StarkNet token and decentralization. So StarkNet has been, so the token was one token was like the joke of a lifetime since arriving crypto. So since arriving crypto, one token, right? So StarkNet didn't have an IC, starting in 2018, refused ICO. 2019, no. 2020, no. 2021, no. 2022, no, until basically now. We raised 260 million, as I said correctly, and we just finally announced a token. The reason for the token to exist is to enable a permissionless decentralized network. Because you need to have a system that is that has this system. I mean, you need a system. Okay, sorry. Sorry. So yes. So because you need a token to make a proof of stake work, and you can't be endogenous to the external system. You need a system that is self-contained. So 45% of all tokens will be minted, will be distributed through the foundation to dev and through grants and for core contributors. So what I'm going to tell you now is the whole point of StarkNet is to focus on dev. Right now, my sole focus is building dev, bringing dev into the mix. And so The only advice I have for you that if you are interested in what we do, try building. Reach out to us, try new things, build new things, talk to us. And so, sorry, yeah. Any question?
So do you have any question? Please raise to Mr. Lewis.
Another question?
What does it mean when you say you can prove something is executed correctly?
Okay, that's a very good question. So the best way to think about zero-knowledge proof or validity proof is basically a compression algorithm for computation. You know, when you compress a file today, you have this pre-processing step of compressing it, right? So you basically have a file, you could share it right away to someone else, and the network, you know, it would take some time, right? Because it takes network propagation. So what you're going to do is that you're going to compress it, and then you're going to send it. So you spend a bit more time, and this guy on the other hand can, you know, get the message faster and decompress it. So zero-knowledge proof basically enables you to do the same but for computation. It means that you have this set of, you know, addition, multiplication, storage operation, all of that. And instead of sending you all the transactions for you to rerun yourself, what you're going to do is a bit different. You're going to pre-process them in a way that I'm sending to the network the transaction, but when I'm receiving the transaction, I actually don't have to rerun themselves. I just have to verify a proof that they are valid and that the output I'm getting is true. So this is what ZKP provides. So that's why you scale a lot better. The scaling comes from not the fact that you are able to, I mean, at the end of the day, the reason why you get scaling out of this is because today the network is capped by the max throughput we allow the smaller machine to address. So the network is capped by the weakest machine in the network. So for instance, for Bitcoin, the weakest machine is going to be a Raspberry Pi. Okay, it's a target machine for Bitcoin. So when you compare Bitcoin to Ethereum, it's ridiculous because Ethereum is looking for a $2,000 machine, like basically a MacBook M1 2021. And if you go to Solana, they tell you, you know, $2,000 machine is actually cheap. We can have a $2,000 machine a month. So you're not comparing the same thing. What ZKP brings to the table is, so there is something ridiculous about this, if you think about it, in this limitation, is that we are imposing the same requirement from this guy in Nigeria to the guy who was running, you know, POS with $100 million at stake. And they're running on the same machine. Why? This guy is making money, the other one is like a kid. Why are they running on the same machine? What you want, ideally for a chain, is that you want to enable the validator, the sequencer, the proof of the staker, to have a $100,000 machine for they care. But still having the kid in Nigeria verify that what he did was correct. And so you're requesting the guy with a $100,000 machine to make a proof that everything he did was valid. So he cannot bullshit the guy in the middle of nowhere. So this is what proving means. It means that I'm proving that everything I did was correct, and I can compress all those operations into a single, smaller proof that I can verify faster and get update. I can update everything that happened by myself. Does it make sense? I'm sorry. Longer story short, I'm going to go a bit slower. ZKP, zero-knowledge proofs, are a compression algorithm. They're a compression algorithm. So it takes addition, multiplication. All those things take time, right? It takes time. So this is a protocol, like a cryptographic protocol, the same way electronic signature are cryptographic protocol that guarantee you that when I'm receiving a proof, and the proof is like a small set of microtrees, to put it simple, I can verify them very, very fast in a couple of milliseconds, but it verifies the amount of computation you did yourself. That's what it does.
How often can so how often does this stuff where sequencer post to L1?
That's a very good question. So how often the Starkware sequencer posts proof on L1? So right now every 8 hours, sometimes 12, depending on if you crash or not. Sometimes it happens. No, roughly between 8 and 12. And with recursion and with more throughput, we expect it to go down to 1 hour. So you expect to get back the proof back to L1 in 1 hour. on L3s, because the reason why it takes so much time is because computational expense in Ethereum. On L3s, it would be much faster because Darknet itself is optimized for computation. So you don't really have to think about you can commit smaller proof more often. Okay, so how do you think about finality? So there is two types of finality. I mean, some people will yell at me for saying that, but basically there is what we call the L2 finality, which is gonna be whatever protocol consensus algorithm you want to implement. Like, you know, let's say tomorrow we want to implement Bullshark and Network, which are like the Nawal, which is like one of the newest algorithm by Sui or whatever. So this they claim to provide finality in a few milliseconds, in a second. So if you believe the proof of stake of start on L2, then you're good to go. But if you don't, then you have to wait until the checkpoint gets published on L1. And so this is the way you need to think about it. So 1 hour from L1 perspective, but for if you are to believe, and most likely you're going to do that, because what most cases is going to happen, you are going to believe the finality on L2. So the main difference in terms of security assumption, if you do this, is, okay, I'm vulnerable to reordering attack, whatever, reordering it over for an hour, but for any decentralized enough network, that's not actually the risk. The main risk you have usually with proof of stake or sidechains is the risk of the hack of the bridge. And in the context of ZK-Rollup, you don't have this risk outside of pure. You can have breach of trust. I mean, I'm not going to name any company that had a breach of trust, but you basically know what I'm saying. So that's what you get. So as a user, you're going to have a look and feel of instant finality or very fast finality. But from perspective of L1, you have to wait longer. Does it make sense? Yes. Another question.
So Louis, how would you think about general DKV and general DKV in the far future? I mean, it's outsourced, like just like we're also seeing our computation power to AWS in the future, where there will be many L1s, and they're also seeing their execution to DKV and like Cairo virtual machine.
So you're asking me about what I think about ZKVM, right? Roughly speaking. Look, a couple of things. The first one is the EVM is a great tool, but it's not the ultimate VM we invented in the history of computer science. And what I'm saying by this is that, like, it's important to be compatible and it's important to support people who want to reuse a contract and so on. But what I think is that if you want to take advantage of the property that ZK-Rollup provides you with, you're better off learning the native language because you're getting much more speed up. And so the long story short is that for people like Aave or for people like 1inch, which have huge code base and audits that costing them millions, I understand the reluctance to learn a new language and rewrite everything from scratch. It's an expense. It's a security issue. It's many issues here. But if you're a new dev writing a new product from scratch, then you're better off writing with the right tool. So that's kind of where I'm coming from. As I said, we have projects and people building backward compatibility tool like Kakarot. So if you want to contribute to that, it's open source, you can contribute. There is a Telegram channel where they are doing all of that. And so, yeah, long story short, you're new, you're trying something new, build using Cairo. If you have like a Bitcoin base or something that already exists, try out Warp, try out Kakarot, but unless you're like, 1inch, I don't think you should have a problem.
Thank you.
Good question.
How will you do the sequencer rotation? Is there any thoughts to that?
You and I, we need to talk afterward. You have a good question. Okay, so that's a question that, so it's still TBD. At the moment, what I can tell you is that we are looking at something like very similar to ETH, to Gasper, meaning a longest chain, signature-based longest chain as for the tip of the chain, and a finality gadget, which I don't know which algorithm we're going to do. So because you have the longest chain, the detail of the leader election in this context is still unknown. The advantage that we have is that we can use the randomness based out of ETH, because the L2 validator have to be following ETH2. So we don't really have to think about randomness or like random or kind of things because we have access to the randomness coming out of ETH. So That's kind of the advantage that we have as opposed to if they twist, because we're there too. Our security in any case depended on L1. So we cannot take leverage on this. So now so the detail itself is unknown even to us. We're still working on it. We're actually, I think there was a post published by my colleague Ilya a week ago. If so, you can read about it. You can read on the community.starknet.io. But we need to talk because you have a very good question. I wonder what you do.
I mean, it's just very useful for, I think, everyone to think about as well. So like if you have a centralized sequencer now, will you need to censor like OFAC transactions? Sorry to put you on the spot, but yeah.
It's a very good one. The truth is, probably. It's like, you know, Uri likes to go to the US. Uri is my CEO. So like, that's why we want to decentralize, because we don't want to go to jail. No, I mean, it's kind of a joke here, but the truth is, I don't know if we actually put it in production eventually, but I know that I think we felt, I actually got very upset when I read that. It was like a meeting, it was like, what? So we have filtered out wallet from, you know, whatever the name of the company that's filter, OFAC, listed, whatever. And I'm not proud of it. But the truth is, as I said, like Uri, I was on the call, he was like, I was like, what? And Uri was like, Louis, I don't want to go to jail. Just, so like, you know, so the only way you can solve this is through things like tools for infrastructure. Make it impossible for you to prevent it. And the problem that you have, especially on all the tech related to MEV, or what I'm talking about MEV here, is basically the OFAC inclusion is an MEV problem. I mean, you can think it as it's an MEV problem. Because if I can sequence without knowing what the transaction is, then I'm done. I'm good to go. The problem that you have is that if you can do it, people will ask you to do it. And this is exactly what's going on with Flashbots. Like the level of depth in which they went to analyze if a transaction is OFAC compatible or not is very deep. They went to the point where they run the transaction and go, like, even place it literally at the bytecode, at the trace level, to know if they were allowed to do the transaction, which is like I was talking. I'm a good friend with Alex Obadia, with the founder of Flashbot, and I was like, dude, what the fuck? like he was like, don't talk to me about it. Don't talk about it. So, you know, and I don't know the open source it, because if you can't do, like, and the reason the open source is because the backlash was so high, and I'm assuming, I don't know that, because it needs a way to make it impossible for them to censor. If you want to, the thing that you have to remember something. If you want to take the risk yourself to do transaction, because you can, because you're in a legislation that they don't care about OFAC, or you're never going to put your feet in the US for whatever reason, then that's what you should be able to do so. And that's why they open source their builder. But at the same time, it's legitimate for people in companies that have like relationships with the US to be careful. And so I'm not proud of it, but we will. I mean, I don't think we do. I don't think we even think about it. But if something happens, we probably have to. So this is where my answer is yes. And that's why we want to do something. Question. Another question from the gentleman that is I think a good question.
Really gonna ask Starknet really awesome question. I mean, you're giving amazing answers. Since Starkware already knows all this amazing cryptography, will you all like figure out some amazing ZK stuff for the mempool? He really knows the question.
So yes, I mean, no. The short answer is that there are three ways to solve that MEV question. So three cryptographic ways. One is cryptographic, the other one is more economical. So what you want is prevent the builder to have a choice into either see what is sequencing or to have no choice because the other imposed him to sequence the way without censorship. So this is called like pressure encryption. So one company that does this is called Shutter Network. The problem that you have with Shutter Network is that it needs a trusted setup, which is not an issue in the context of a mempool because The problem is that the trust is set up is in n squared. So the number of validators that you have is you have to create a pool that is the messaging is n squared, and so the blow up of complexity after a certain number of operators is too high to be practical in a realistic setting of a chain. Now the second thing that you have is so one thing people are trying to do also is like using threshold. So this is called threshold encryption. So what you want is threshold encryption. There is a paper called McFly that does this, but even this one also has n squared complexity. The second one you want, there is actually discussion with Justin Drake about Bogota. They are looking. I know the EF is looking at something called MEV smoothing, which I don't exactly know what it entails, but basically the way I understood it that so I don't know if you know, but the mempool is a local view. No one shares the same mempool. Otherwise, it would be itself a blockchain. Like the whole point of blockchain is agreeing on the truth. So every mempool is its own mempool, and no one knows exactly what the other is saying. Because maybe a transaction didn't come through, because maybe a transaction was replaced. There's plenty of reasons why you and I don't see the same thing. And so MEV smoothing, the way I understood it, is that you have to declare 1 second in advance what block you're going to propose, and other people in the network needs to say, I'm seeing this transaction and I'm agreeing in the ordering. So they are agreeing on the ordering at the second scale, right before inclusion. And so if you do this, what you're gaining is that what is non-MEV based solution? Non-MEV based solution means that it's following the ordering of the max fee. Basically, it's not what they call on Etherscan unusual ordering. And so when you have unusual ordering, this is when you have MEV. That's actually how Etherscan define MEV. That's how every explorer would define MEV. And so what I'm trying to say here is, if we were to be, what you need to make this happen at the true cryptographic level is basically n log n key generation, which is unknown at the moment. N log n key generation in messaging complexity. And ideally you would like a one-shot n log n complexity, but like no one knows how to do it. And but we have people like, I'm literally coding on my working on this stuff, I'm trying to push him to work on this. But we don't know if it's a breakthrough. It requires a breakthrough in cryptography.
ZK point of sale system?
So ZK point of sale system. So I'm not sure what it means. What I can say is that I'm still waiting for a company that's going to create just a good payment system. Before even the proof of stake, the proof of sale. Even before the proof of sale, the problem that you have is you want a system that can process. Okay, I'm going to tell a story. So recently I had to send money from France to the US. It was a bit of money, not a lot. And the money went through, so I don't know if you know how international transfer works. Basically, it goes the following way. Your bank has a correspondent bank in the US, and the correspondent bank is like the direct connection, and then they relay to the bank, the end bank in the US. And so the thing goes this way. So my bank in France is like a 100-year-old bank, quite famous. The intermediate bank in the US is Mellon Bank of America. Mellon Bank of America is the oldest bank in the US, created by Alexander Hamilton, founding father of the US. The money goes through, and my recipients say, I didn't receive it. And I'm like, what do you mean? I sent it like 3 days ago. Like, I didn't receive it. And so I asked my bank, 2 days, they don't reply. They say, okay, I don't know. 4 days, they tell me, okay, you know what? It's actually locked in the US, it's locked in the recipient. I tell my guy, you know what? The money is in recipient, also there is a weekend in between, you're already a weekend. The money is locked at your bank. So the guy spent an hour and a half trying to justify to the guy that the money is legit, it's not like a fraud or something. And then the money goes back to me. I have to do exactly the same thing, the money goes back, eventually clear and get to the bank account. What I'm trying to say is, crypto is a major payment system already. The problem that we have is that it's not in the end of end users. And so there is no point. I mean, before getting to DK point of sales where you can verify payment instantly and so on, what you need is actually people accepting USDC, USDT locally as a mean of payment, and that is something I haven't seen so far. I mean, that's the answer. The answer is did someone build it? So maybe. So the answer is no one is building it, as far as I know. Anna, this lady. Actually.
Okay, sorry for interruption, but the time is out. So now there are 30 minutes for you guys to continue to build your project.
Mm-hmm.